we are discussing about electrical protective devices. We are discussing about mainly the devices that are found in a consumer unit or a customer interface electrical unit. We will definitely discuss about this. This is an MCB in full, a miniature circuit breaker. We will also be talking about MCBs, the ratings and what they mean. My top boss, did you know that even this switch, which is a double pole switch or a DP switch, is also a protective device? Would you agree with me? It is indeed a protective device simply because it protects against any contact with the electrical circuit. So it offers the insulation, especially the plastic part. And whenever you are operating it, you definitely are safe. But it does not offer the automation when it comes to protecting you. Now, I will discuss about the protection offered by an isolator and that offered by an MCB. What is the difference between the two? My top boss, stick around and thank you so much for joining us on this live stream. Just let me know which part of this world are you watching me from, and if you'll be watching me on recorded version, I will really appreciate when you mention your area. My name is John Gatehi and this is Top Boss Electricals. So when it comes to protection of circuits, we normally find that there are so many MCBs in a specific electrical panel or an electrical installation such as this one where we have all of these MCBs. First to understand is that electricity flows back and forth from a source. In a previous video that I did, I discussed about that and I was able to demonstrate that we have two cables, two distinct cables that carry that power. If let's say we have a red cable and a black cable starting from the source going all the way to the appliance, or the installation and then back, that loop is what we normally refer to as an electrical circuit. Now, in a home or in a business distribution, you find that power is supplied with two conductors, the phase and the neutral. The phase is where current is flowing back and forth from the source, which is the transformer, and then it flows back through the neutral path to the transformer, completing that circuit. Now you may wonder, why is it that we only have two conductors supplying power to either a home or a business installation, yet we have several cables in a consumer unit or several circuits? What happens here is that we have power supplied, yes, to this point using two cables. But very important, those cables end up serving power to different circuits. Why do we have several circuits at the point where we have the consumer unit powering or supplying power to a home? It is simple. It is because different circuits have to be protected differently. For instance, a light circuit that uses this LED bulb, has to be protected and cannot carry or does not have the same amount of current flowing through that circuit compared to, let's say, a geyser, a heater, or an electric cooker. What is connected on the other end is what determines the amount of current that will be drawn from the source. And that, in essence, also determines the protective device that will be placed there. Assuming we have a cooker circuit which is connected at this point, and we also have a light circuit, the cooker drawing 30 amperes plus, and this bulb drawing less than 1 ampere or even less than 0.5 amperes, then it means that those are two different circuits. What can actually burn or blow these LED bulb cannot cause any harm to that circuit of a cooker, which is 30 amperes or even more. The reason why we need to use different devices when it comes to these circuits is so that we may protect the individual appliances that have been connected to those circuits. For instance, if we connect a 20 ampere MCB, or we connect, like, let's say a 6 ampere MCB to a 30 ampere cooker, we have done an injustice to it because it will keep on tripping. It has already tripped. Reason being, the cooker draws a lot of current at any given time as long as it is in use. All right. So, for instance, this one is a 6 MCB, as we can see. It will draw a lot of current. A cooker that is rated 30 amperes plus is supposed to be connected to a bigger circuit breaker so that in case of any issue, it will definitely be protected. The intention here is not that the MCB keeps on tripping as long as this appliance is in use. No, no, no. We want to ensure that every time the cooker is supposed to operate, it operates at its optimal performance. We also want to make sure that if it is a bulb, if it is any lighting circuit that has been connected, it is operating optimally or properly and without any interruptions. All right. So we are going to discuss about the various sizes of MCB. For instance, we have a 10 MCB. We also have a 6 MCB, like I've mentioned, and we have 20, header 20 here. Yes, this one. So let's say you have a circuit for sockets. The reason why you have a circuit for sockets is because the appliances that will be connected to the sockets are definitely different from the appliances that are connected to a lighting circuit. You find that if in a lighting fixture you will have a chandelier, or panel lights. These lights may be drawing very low amounts of power. Therefore, you need to connect a very low, uh, calibrated MCB so that in case there is any problem, in case there is an overcurrent, in case there is a short circuit, and remember, a short circuit will be in very little magnitude in this low powered circuit, and therefore you are supposed to use a low rating MCB so that it can be able to trip at the minimum load or at the minimum fault that occurs in that circuit. For instance, in this case, the lighting circuit. When we talk about a socket, my top boss, assuming that you have connected an iron box or a washing machine, which probably draws a current of, let's say, 20 amperes, or is that too much? 20 amperes. If it draws 20 amperes and your circuit is below 20 amperes, or it is 20 amperes, it means that that is not the right protection because it will keep on tripping even if there is no cause for the tripping. But if you just have something that is slightly above, like let's say 25 amperes or even 30, in case there is a problem or a short circuit that is of that magnitude, 30 amperes or even more, it will definitely trip, saving that appliance from any form of damage. Now, we also have another important thing to mention here. When it comes to MCB, we have an MCB and an isolator. These are very two different things. This is an example of an isolator. It is manually operated. Many or all isolators are manually operated. In case there is an overcurrent, they will not trip on their own, meaning they are not automated in any way. The good thing about an MCB, miniature circuit breaker, is that in case the current exceeds its rating, it will automatically trip, and assuming that there is a huge short circuit that is happening, huge in this case, more than 63, the sole purpose of an MCB is to detect that the current drawn from it is above its rating, and then it trips shutting down the supply of electricity in that installation. So assuming that in a home which is using 63 amperes, MCB has a short circuit or an overcurrent. Now let us define these terms. What is a short circuit? What is an overcurrent? What is the difference? A short circuit is drawing of high amounts of current from the source at the same time rapidly. I don't know whether that is the right definition, but you draw a lot of, like, let's say when you short the terminals between the battery positive and negative terminal, that is drawing a lot of current very fast, or drawing a lot of current within a very short time from the source, you know. So that is what is referred to as a short circuit. An overcurrent is whereby an appliance has been connected to a source of power which draws excess current than what should be drawn from that source. For instance, a 63 ampere MCB being connected to a 100 ampere motor, it means that the motor will draw a lot of current from this MCB, causing that situation to be an overcurrent, and that will definitely lead to the tripping of that MCB. So that is how it protects. While in an incident where we have an isolator as the main switch in that connection, we find that that isolator will not trip. Therefore, it will result to a lot of issues. Remember, these protective devices are connected so that they can protect the circuit, they can protect the home, or they can protect the building, assuming it is a business. So if there is a motor that has been connected which draws more than 63 amperes, it means that even the cables that have been connected in that circuit are not able to supply that current to that motor. Why? Simply because the electrician who was designing that installation or that circuit did not have a motor in mind or that load in mind. And that is why they used lower powered or lower rated devices, protective devices. So if you go ahead and have a motor which draws a lot of current, then it means that you are predisposing that electrical installation, a home, into a lot of issues. Let's say the cables that have been connected are of low gauge. It means that that current will definitely lead to overheating of the cables, and that overheating may result to a fire. All right. Now, this is where we also need to talk about the size of the cables. The sizing of the cables is very important. A 1.0 or a 1.5 may be ideal for a lighting setup. But when it comes to sockets, when it comes to machines, when it comes to motors, heaters, that is dangerous simply because this cable is not of that purpose. Because the size of the cable in terms of millimeters is very, very crucial here. You know, when it comes to the diameter of that cable, it matters a lot. When we were in high school, we learned in physics about the resistance of a wire, the resistance of a current carrying conductor. And we learned that the cross-sectional area matters a lot. The diameter matters a lot. The material that is making that copper, that conductor, matters a lot. When you talk about copper, aluminium, these are materials that are very good when it comes to the electrical conduction, if I may say so, you know. And if you use iron, for instance, there is a lot of resistance simply because this is not a very good conductor of electricity. There are some cables that are acting almost like an insulator, which are used for wiring in today's world. And that is very, very bad because you may predispose that customer to a lot of issues. And among them is definitely fire, you know, in case the insulation burns or in case these cables come in contact with each other due to overheating of the insulation, it means that there is a huge problem right there. Now, there is also another important device which is referred to as an SPD, or a surge protective device. We find that these devices are in DC ratings as well as AC ratings. What does that mean? Defining terms here: DC, direct current; AC, alternating current. When it comes to AC, we are talking about the national grid, we are talking about the transformers, or we are talking about inverters that have, converted that DC, the direct current, from being direct current, of course, to alternating current. So AC devices or protective devices operate in that manner in case there is a surge that is coming from outside. In fact, let me just bring it closer so that you may be able to see. Right? So this is an SPD, a surge protective device. Now, what you see here is we have the L, the line or the live connection. We have the N, or the neutral connection. And then at the bottom section, we have the earthing connection. Why is that important? Its purpose is to detect any surges that are in that line and neutral, and then they dissipate it directly to the earth using this termination that is below here. So every time that the wiring has been completed or the wiring has been done, very important to note is to ensure that at the consumer unit where we have the earthing connection, it is connected to the earth, And another important thing is to ensure that a home which has an electrical installation must have an earthing system that is working. Homeowners are supposed to carry out electrical installation. They're supposed to carry out maintenance within a period of 6 to 12 months. This is to help them guarantee their own safety, guarantee their own protection when it comes to electrical installations. Because if at all the earthing is not working, even if it is installed, even if the continuity of that earthing, is working all the way from the consumer unit to the individual circuits, how do you determine continuity? Using a multimeter, continuity of the earth, place the probes at that point, and then you test for every other part that is supposed to be earthed, So assuming that we are talking about this circuit, if it is this one, where is the connection connected? So you find that this has a problem. Why? The earthing is not continuing. How about here? For this instant child, it is continuing, right? So basically, that is how you test. When it comes to the lighting, you also do the same, So for this, you test also, and you are supposed to get that beeping sound, which indicates that there is continuity. And that is not the only indicator that you have an earthing connection that is working. You are supposed to test for earth resistance. All right. What is the earth resistance of that earthing installation? So you need to be very, very sure that it is working properly. So let me just take the camera closer. Don't know whether you'll be able to see that. So there we have the consumer units. And I'm going to demonstrate, like I've demonstrated, the use of the multimeter in testing for that earthing continuity. But you know, the ultimate test for earthing is definitely the resistance test, all right? So if we have that, we want to test for the continuity using this multimeter. A digital multimeter is, you know, a lifesaver, you know. It will save on a lot of issues, especially while at the construction site. So all you need to do is to place your, you know, that pointer right there. And then when the probes come together, find that there is zeros there. So we are moving from infinity on the screen, you know, to zeros. Zeros indicating negligible, almost negligible resistance. All right. So, and the beeping sound, you can hear the beeping sound is an indication that indeed there's continuity, right? Top boss Joe Muratha says, top boss, I have a question. So what causes current to be detected on the insulation of a cable? What a good question. And Joe Muratha, thank you so much. I appreciate seeing you here. Basically, if there are leakages, if you place a tester on that cable and then there is presence of current, in many cases, the insulation is poor, or it definitely means that there is uh, leakage, right? There is leakage of current. So once we set our digital multimeter at that point, we definitely can test for that. So if we want to test the continuity of these earth connections from this point to this other point, you find that there is that beeping sound. Can you hear it? Right. So if we want to test whether the entire box is actually earthed as we expect, we simply place it there. It is earthed. All right. So that is very, very important. And we can have fun at it, you know, just testing things, and then that one will prove that the earth connections are actually intact. But the question will be, is that home really safe? Just by going with that test. Is the home really safe if we go only by that test? I don't believe so. Until we get a proof of the earth connection. So if we go by what we have here, so let me just so this is the earth wire that is meant for, you know, a heater in that circuit that is coming all the way from the consumer unit. So let us go ahead and also test it, isn't it? So using our multimeter, we want to ensure that there is continuity all the way from the consumer unit. So what we need to do is to place our probe at this point right there, and then test the earthing. So you can hear there is a beeping sound, and also there's zeros, meaning that that resistance is almost negligible. Okay. Now, when it comes to our SPD here, our surge protective device, you can also test, see that it has to be connected to the earth connection. And this is where we were discussing that if the incoming power, which is supplied by the line and the neutral, flows first to this SPD, and then it is looped, you know, it does not flow through. But as you can see at this point, let me just have the camera closer so that you can be able to see it clearly. Are you passionate about electrical installations? Is it something that you love? If you are given another chance to study something, if you are not an electrical student or if this is not your career, would you still choose electrical? I always say that given a second life, in my second life, I will still be doing electrical because I love it. I'm so passionate about it. And I learned a lot of excellent connections from the work ethic of my father. My father was a part-time, was a teacher and a part-time carpenter. Yeah. So you see, that is what we have. So at this point, power flows all the way to this SPD or the surge protective device. From the surge protective device through the face, as we can see, and then it loops to this double pole MCB or the DP MCB. So the purpose of this is to protect against surges. In case there are surges that are detected, they will simply flow through this SPD and to the earth connection and then all the way to the ground. But as we have said, the earthing must be perfect. Conditions for that SPD to help or to protect the homeowner against a surge. A surge is very, very high voltage that can damage electrical appliances. Many electrical appliances are not destroyed by current, but they are destroyed by voltage. So if an appliance is supposed to use 100 volts or 110 volts AC, but the volts that flow through it are, let's say, 200, that means that that is double what it is supposed to handle, and it may damage that appliance. In many cases, you find that the surge is up to 300 volts. That is quite dangerous. It will simply destroy that appliance. So the work of this is to cap, to cap the voltage. As the voltage rises through it, it will definitely cap it and protect it, protect the appliances from the surges. And then from there, we loop the neutral all the way to the, this is what we refer to as the DPMCB. As you can see at this point, this is a DPMCB. And I will also be sharing the difference between the DPMCB as well as the, we just have it closer. So when you look at this marking here, this is an MCB. If it were a mere isolator, you would not have all of this, and I'll be sharing that in the coming videos. So if you have not subscribed, kindly subscribe so that you don't miss that episode. So I'll be sharing that. So the good thing about this protection here is that in case there's an overcurrent, it will simply trip. So it will save any appliances that have been connected and are drawing a lot of current from from any electrical overload or issues. Very interesting is our third device here, the third protective device, right? This protective device is referred to as what? Top boss. What is the name given to this device? Hmm? We have said this is the surge protective device. Say that this is a DPMCB. What about the third one? What is the correct name given to it? Very, very important. Many homes miss this. Many electricians don't consider this. ELCD. That is great, Joe Muratha. And Joe Muratha, thank you so much for being here and being very proactive, not just watching. Yeah. What is the correct name given to these before we can go to the common ones? All right. And these ones, like I've explained, it is very simple to understand their operation, but this is in fact the most important one, but many people miss it. You know, many people don't recommend to their customers. I don't know why. Very, very important. An RCCB, which is rated, you can see it is a 63 ampere and it trips at 0.03 amperes or 30 milliamperes, and the time 0.1 seconds. What does that mean, Top Boss? Right. So we are going to discuss about that as well. Let me just move my camera from that angle so that we can continue with the discussion. So if you're finding value out of our today's stream, my Top Boss, give this live stream a thumbs up, or if you'll be watching it as a recorded version, kindly give it a thumbs up. Right. So the RCCB is in full residual current circuit breaker. But what is the importance of that in a circuit? And how is it wired in this circuit? As we can see here, we have said that from the SPD, we have the DP-MCB, and we also have what we refer to as the D. From the SPD, we go to the MCB, miniature circuit breaker. I will also be talking about the MCCB. What is MCCB in full? Top boss. Can see Joe Muratha says residual current circuit breaker. That is the RCCB. Yes, very good student. Thank you so much, Joe. Residual current circuit breaker. Its purpose is to detect that there is some current that is flowing out. The key word here is out of the loop. We have said that electricity flows back and forth in a loop, right? So you have like a cable here, and so electricity will flow in this loop. So the purpose of this RCCB is to monitor the current that is flowing in the loop. In case there is any current that is flowing outside, assuming that you come in contact with the bare conductor. For instance, this was a hot wire. This was a hot wire, and then you come in contact with this part here. All right, it means that some current will flow through you. Now, the purpose of this RCCB is to detect that there is some current that is flowing out of that loop, and it simply trips within microsecond. The reason why it does so is to shut the electricity supply, so that if there is someone that is receiving an electric shock, they are able to have another chance at life. All right, so it will save them. Molded case circuit breaker, that is the MCCB. Thank you so much, Joe Muratha. I really appreciate it, and you're absolutely right. Looks like you did some good research when it comes to this live stream. So when there is the leakage, in fact, for this one, the rating is 0.03 amperes. That is 30 milliamperes. Very, very small current. So in case that is the amount of current that is flowing through a person, which means it is flowing outside that electrical loop, then it means that it will simply shut itself off or shut itself down, and in that manner shut all the supply, the electrical supply or the circuits, it will shut them off, the supply. So even if they are on but this is off, it means that they don't have power supply, they are starved. That means that everything in the home will be off. Assuming that you are using an electric cooker, you are preparing something in the kitchen, it will be off. The lights will be off, and the washing machine will be off. Now, let's assume that someone is receiving an electric shock in the dining. Probably in the dining, we have a dispenser, a water dispenser, which has some leakage, and that leakage has gotten to someone, and someone is receiving an electric shock, or that dispenser is faulty. It will definitely mean that this RCCB will trip and it will shut the entire supply of electricity or power in that home or that electrical installation. So every other thing will be shut off. But, but it is important to take note here that the wiring is very important. How that RCCB has been wired is very, very important. Joe says, I'm an electrical technician. Awesome, awesome. How do you like the electrical technician or the electrical work, my top boss? First of all, where are you working from, Joe Muratha? I can tell that you're a very passionate electrical technician. So assuming that somebody wired these RCCB and prioritized the sockets that are in the kitchen, and the dining room, and someone is receiving an electric shock in one of the bedrooms, assuming that Joe Moratha is living in a 5-bedroom mansion. Okay, you could be living in a bigger home than that, Joe, because I think you'll be very wealthy. And somebody who was wiring that home prioritized the kitchen and the dining room and the sitting room, where they wired the circuits to the RCCB. If someone is receiving an electric shock in the bedroom and that area is not covered or does not have its own RCCB, it means that they are not protected. All right. Assuming that two people in that home are receiving an electric shock, one is in the bedroom where there is no protection, another one is in the dining room where that room is covered in the wiring by having this RCCB installed. The person that is in the dining room will be saved, because once it trips, it will definitely shut the supply of current or electricity in that area where the person is receiving an electric shock. And the person that is in the bedroom where the RCCB does not cover or it was not wired, then they have a problem. So the wiring of the RCCB plays a key role in protecting the users in a home. So if the entire home electrical installation passes through the RCCB, it means that even when there is an issue with the lighting, the RCCB will trip. Even when there is an issue with a charger, a mobile phone charger, or that Wi-Fi router adapter, it will definitely trip the RCCB, protecting the homeowners, protecting even the devices, the gadgets that have been connected to that circuit or the power. Why am I dwelling so much on the RCCB? Because these other ones have been existing for so long. People normally connect this one. It is almost like a default function for so many people to have the MCBs, but the RCCB is where people draw the line. And by people, I mean electricians as well as the homeowners or people who have built their homes. If you are not going to install the RCCB, then you are putting yourself at risk, predisposing your loved ones or people who will dwell in that home into an electric shock, because they are not safe. Now, quickly, before I wind up moving to the MCBs, it is also important to come up with circuits specific circuits that are able to be protected against a short circuit from the specific MCBs. What do I mean? Different MCBs or miniature circuit breakers have different ratings. For lighting, we use smaller ones. We can use even 3 amperes. We can use 5 amperes, depending on the number of lights and the lighting fittings that have been installed. All right. So when we go to the sockets, we use 20. And it also depends on the socket wiring that has been done, be it the ring circuit, be it the, we also have, like for instance, what we have here, is this radio or is this ring? So let me just explain it, and I've done a video on that. From the consumer unit, of course, coming from one MCB, the circuit flows through this conduit, the white conduit, as you can see, and then it goes all the way to the first socket that is down here, and then it extends to the second socket, and that's it. So is this one a radio or is it a ring? Joe Morada comes in strong again and says, I love your content. I learn a lot in my line of work. Thank you for the good job. Thank you so much, Joe. I really do appreciate you for that feedback. So from the consumer unit, it goes to the first socket, second, we could even have another one here, and then that's it. We know that there is another one that goes back to the consumer unit. So which one is this one? And Joe is very right, says radio. Why? Because radio starts from the consumer unit and it goes to a point where we can say a dead end. Yeah, it does not form a ring, it does not go back to the consumer unit. But when we talk about a ring, it forms a circle, a ring, just as the name suggests. It starts from the consumer unit, goes to the first socket, the second socket, maybe the third, and then it goes back to the consumer unit, forming that loop or forming that ring. And that is why we have the name, the ring circuit. Thank you so much, my top boss, Joe, for that. I really do appreciate. So that is the ring socket, the radio socket wiring. And we also have ring circuit when it comes to the lighting, you know. So if you have lighting such as this one, it flows all the way to this bulb, and then you have another bulb, and then it goes all the way back to the consumer unit. Then that one is ring when it comes to lighting, and it is very, very important to consider ring. Most of the people do not factor in ring circuit simply because it is costly. When you are coming up with the list for the materials, the customer may suggest that you are very expensive and decide to go with another electrician. But if you go with radio, in most cases, you find that it does not use a lot of materials. Therefore, the quote may not be too high, and people may prefer that one. All in all, at the end of the day, it depends with the customer's preference, what they want, as well as your recommendation. Always go for the best as an electrical technician. Give them the best solution. What is the advantage? Am I back, Joe? Sorry about the sound issue. Sound is back, right? Thank you. So assuming we have our socket in one part of the room, like let's say this is the consumer unit, CU, and then we have first bedroom, and then it goes to the the first bedroom, first socket, it goes to the second socket, and then it goes back to the consumer unit. So you find that power flows through this side, and in case there's a problem here, this socket is not affected in any way. Power will continue to flow to it from this other side, whether you are using the left or you couldn't see from there. So let me just so this is what I mean. This is the CU, and then we have the first socket at this point, then the second socket, S2, S1, right? And then we have S3 here, and then back to the CU. So assuming that S1 has an issue, lose connection, or maybe this wire is broken at some point, then S2 and S3 will continue to work properly. So this one is in a ring circuit, right? But a radio will come all the way from the consumer unit, go to S1, and then go to S2, and probably that's it. We also have another type of connection which extends from here. And what is the name? What is the name given to this connection here, or this connection? Do you know about it? That is an assignment for today. The socket that extends from a ring, what is the name given to it? What is the name given to the socket that extends from a ring connection? So assuming this was going back to the consumer unit, and assuming it was a ring, and then we have an extension from one of the sockets, then we give it a name. Yeah. So that's why I'm asking, what is that name? And by the way, when we talk about sockets, when it comes to ring connection, does it really matter whether it is a twin socket or a double socket? For instance, if we have a double socket, then we have a single socket. Can we say that a ring is only connected with using double sockets, and radio is only connected using single sockets? Or do we define and say a ring is defined by the wiring, not by the sockets that you install? Yeah. So let's assume you are using twin sockets only or double sockets. These are UK sockets. Look at how incredible they are. They really grip the top plugs very well, if you may ask me. They really do a good job, you know. And you also have a single socket. You refer to them as, for these double, do you refer to them as double, or is it twin sockets? So even if you are to connect double or twin and a single and have the wire in a ring or radio, it still makes sense that it is either defined as a ring circuit connection or a radio circuit connection. All right. So that is that. When it comes to the MCBs, that is how you connect. We shall be talking or discussing about more protective devices in our subsequent videos, and I will be sharing much more information. Thank you so much, my top boss, for your time. Special thanks to Joe Moratha. You've been here and not just being here watching, but contributing through the comments that you have given, and it really means a lot. Thank you so much, Joe Moratha. And if you have found value out of our today's live stream, smash that like button. And if you'll be watching as a recorded version, I also do appreciate you so much. Just smash the like button if you find some value somewhere, and also subscribe to our channel, Top Boost Electricals, if you haven't. And I really do appreciate that. Joe Moratha says ring connection is on the wiring, not type of sockets used. Absolutely. That is very brilliant of you, and I agree with you. So thank you so much, my top boss, Joe Moratha. Thank you so much, my top bosses, for being here and catching this live stream. Thank you so much for you who will be watching this on live stream. My name is John Gatehi, and this is Top Boss Electricals. Goodbye for now. See you.